Hello, can you hear me?
Yes, sir.
Okay, well, so you can hear me properly, right? Is there
Yes,
any
sir.
background noise or
No,
is
no,
it
no, no,
okay,
sir.
right?
All good.
Okay,
It's
I hope.
okay.
Okay, great. So this is the just season of marriages and also there is some background noise, but I hope this is okay to all of you.
Okay,
Do let me know if at any point you are facing any difficulty. Well, so how's the preparation going on for everybody?
Good, sir.
Good. Okay, so have you covered the content or is it going on or
no, sir, it's going on. It's not so easy actually.
okay, why? Where is the issue?
No, actually, problem is there so many properties are there. Actually, no, like SVD is okay, but there is
Uh,
properties of SVD. While
okay.
doing SVD, there will come that A transpose and A transpose A two items. We have this. Then there are so many properties of them,
Yeah,
and
something you have to
I
have to
know that
put
we have to
your
memorize. And I found some
correct, correct.
questions from PYQs. Actually, they greatly ask about the properties. Which of them is
Okay.
true? So it's a bit difficult.
Yeah, well, so you can take ideas from PYQ and try to solve the mock also.
Okay, sir.
Okay, that will give you some idea. So anyway, in today's sessions, what I thought rather than discussing the content in like in deep way, like we are usually discussing in open session, right? So rather than going all derivations, all what we will do, we will quickly go through the content, like just brush up on the concepts, right? And then we'll try to solve. So I have collected some questions which we have already asked in. Some PYQ. So we will try to solve those questions. Okay. So for more clarification for this, from uh, you can look at from the open session and all if you need. So I hope this concepts regarding PCA and derivations and all is it clear to all of you, right? That all the derivations and all the linear algebra mathematics, is that okay to everybody?
Yes, sir. Theory is okay.
Okay, theory is okay, right? So we'll try to
Mm.
solve some question. Maybe that will give you some sort of idea, right?
Yes, sir.
So, well, so let me share my screen. Okay, so let's start the session. Can you see my screen? Is my screen visible to all of you?
Yes, sir.
Yes, sir.
Okay, so I have collected some questions. You can see I have some blank pages all as well. So we'll try to solve those questions. Okay. Anyway, so let me give you just a brush up on the concepts of PCA. Okay, so I will. So in today's session, so as week 5 and week 6 already done, so we will discuss week 7 and week 8. Okay, so our major focus will be on week 7 and week 8. So from week 7, so the main concept is called PCA. So PCA stands for Principal Component Analysis, right? So why do we use PCA?
For dimensionality reduction.
Correct. So whenever
And
you have
also noise
lots of
reduction,
data,
sir.
right? So suppose you have 10 measurements of each student's, right? Then let's say, and in some with along with, so what are the those 10 measurements you can take, height, weight, and marks in subjects. Okay. Then let's say, so you have some, some like lots of students in a class. So if you have lots of data, right? So it's difficult to deal with that, right? So what is the basically, if you say the goal of PCA, the principal component analysis, so it's the goal is to reduce the dimensionality of to reduce the number of variables, right? I can say, so to reduce the number of variables or dimensions, so to say. So reducing is okay, but we have to keep as much of the original information, right? Right. So what do you mean by original information? Original information as possible. So we have to uh, keep in mind these things. So first of all, so you can think PCA as a, it's a kind of data compression technique, right? And this is a data compression technique, but without losing much information. Would you agree with me? Yes, Vaikun.
Sir,
Vaik-
today week 6 and week 5 and week 6, or what is?
no, week 7 and week 8. So week
Okay,
5 and
sir.
week 6 is already done, right?
Okay, sir. Okay, sir.
Yeah. So see, you can think this PCA as a, you know, kind of data compression technique. So we have discussed in open session also this part. So data compression technique. So this is the data compression technique. But
Sir, excuse me, sir.
yes,
Sir, when we actually compress a photograph or something like that, a JPG image, is that a PCA?
yeah. So
Thank
some see maybe you can see one second without losing much information. Okay, so there is a role of rank also, right? So you can see, right? See, maybe in one of the open session you can see, so like that Einstein forehead, right? So those are some similar information, right? So if you will reduce something based on the rank and all, so that is just, so it will first of all, okay, for example, you have images, right? So some 1,000 x 1,000, right? So it will so there you need too much storage, right, to store the original image, yes or no?
Yes, sir.
Correct. So what you will do, you will compress the image so that like without losing too much information, right? So that is the idea about principal component analysis. One thing you can one way you can think of, like in diploma level. So I think there are 12 subjects or 10 subjects, 10, right? In both diploma, right? In diploma in data science and diploma in programming. Hello.
I
Yes,
think
sir.
it's
Yes.
12 subjects. I have not. Yes, yes, 12, 12, 12.
12 subjects, right? So some subjects for it, okay. So let's say there are some 100 students, or let's say 1,000 students, right? So it is bit difficult to visualize this, right? To deal with this thousand, if you want to plot this 1,000 student and 12 subjects. There is some background noise, can you please, yeah, thank you. Then it is a very difficult, right? Yes or no? So what you can do, can you reduce this 12 subjects into like this uh, diploma in let's say data science and diploma in programming, yes or no, for all these
Yes, sir.
students, right? So this is kind of dimensionality reduction without losing too much information. So once you will deal with, you know, real life data, you will get clear idea about this. So what is the first of all mathematical way to deal with this? I mean, how will you start first of all for to compute the PCA? See, I'm not going to discuss all those, you know, that we have discussed in open session, that we want proxy, and that proxy is something perpendicular to that point and all, right? And we did lots of linear algebra thing there, so you can check that part. So today's session is just about quick revision about of the content. So okay, well, so how will you start to compute the principal components? What are the things you have to keep in your mind? What are the key steps?
You should
Anybody?
take where variance is more.
No, I'm asking if you want to compute, let's say, principal component first principal component, what should be your approach? How will you start? So I'm talking about the mathematical way.
Find eigenvalues.
Okay, that is the first step. No one is able to answer. I think you guys have done the GA as well, right?
No, sir, centering the data, centering the
Yeah,
data,
yeah,
then finding the covariance matrix.
correct. So first is the mean vector of the data points. Okay. First point is we have to calculate the mean.
Sir, a small question here, sir. Sir, in the exams, the data will be centered at zero only. They promise.
Yes. No need to center.
Yes, sir. Thank you.
Okay, but for a second, if you have time, you can cross check also. Okay, mean of the data is 0 or not, but it will be centered only. Okay, so what is the second step? Once you calculate the mean vector of the data point, then the second part you have to
Find
calculate the
find the
covariance matrix.
covariance
Yeah, and how will you find the
one
covariance
one
matrix?
by
So that
one
C is equal to 1 upon n.
one by n x extra.
Yeah, xi. So since we are just assume we are calculating the mean, so I'm dealing with xi minus x bar and xi minus x
Into
bar transpose. So
one
if x bar
transpose.
is 0, then it will be summation of xi into x bar transpose, right? Is
Yes,
this
sir.
clear to everybody? Yeah. So
Yes, sir.
you can write this as like this also, summation of xi dash, let's say xi dash transpose. Just so here xi dash means I'm saying xi minus xi minus x bar. Is this clear?
Yes, sir.
What is the third thing? So you need to calculate the eigenvalues
Ma-
of covariance matrix.
Eigenvalue of covariance matrix.
Yeah, very good. Eigenvalues of covariance matrix. Then we need to calculate the eigen
Eigenvector.
vectors of covariance
Vector of
matrix. And then what is the next
projection.
before
Projection.
projection? Yeah, that is a projection. Yeah. So that is something I can say transformed, right? Data points, right?
Sir, do
Yes,
we
yes.
need to normalize eigenvectors?
Yeah, that is something you have to do. We'll solve some questions, don't worry. So one dimensional PCA.
Mm.
So in this MLF thing, so in exam and all, you will get for one dimensional actually, because calculating, things like for three, it's a bit difficult actually. Well, so what is the next then? The if it is asking, see, you can stop here if it's just asking what is the first principal component. Later you can calculate if it is mentioned the reconstruction error, right? And
Yes, sir.
how will you calculate the reconstruction error for one dimensional PCA? Okay, so this is the way. Okay, first of all, how will you calculate the this is something, this eigenvalues we have to convert in normalized, right? Normalized way, yes or no?
Yes, sir.
Right?
Yes, sir.
So that is something we have to keep in our mind. So we have to normalize. What do you mean by normalize? We have to divide by the
Norm.
norm of that vector.
The length.
And what is the next step? So basically before transform part, so we have to find that projection, right? So okay, let me write the notation so that it should be clear to everybody. Just so what I mean by transform part, so let's say I'm saying uh, let's say xi tilde. Okay, so xi tilde is nothing but it's a xi dash transpose w1, or I think in lectures professor have taken u1, right? Should I take u1? Let's take u1. U1 and u1. So if it is just about one dimensional, right? Yes or no? But later what you have to do, you have to add the x bar. Yes,
Yes, sir.
is it clear to everybody?
Yes, sir.
Yes, no, all right. Right, I'm okay. I mean, are you okay with this, everybody? And then the final thing is,
Yes, sir.
suppose it is asking the reconstruction error. So reconstruction error. So what is the reconstruction error? Usually we denote by J. And what is this? And 1 upon n. Summation I is equal to 1 to n. Norm square of this xi minus xi tilde square. So are you getting right? What is this xi dash? I'm denoting this xi dash is nothing but this one, right? Xi minus x bar, the centralized version I'm using. Correct. And the final thing, if I will ask, what is the projected variance? Then how will you write? Projected variance is what?
Largest eigen value.
Largest eigenvalue. So let's say I have lambda 1. Okay. Okay, so far so good. And here, see, once you will calculate the eigenvectors normal in normalized form, so I will choose u1, u2, and so on, such that lambda 1 is greater or equal to lambda 2 is greater or equal to, like this, right? So u1 will be corresponding to largest eigenvalues, and then u2, and then u3, and so on. Okay, is the idea clear? Okay, is the are you able to uh, like understand this formula and all? Yes,
Yes.
no? Any doubt? Okay, great. Then if that is the case, let's try to come up, solve this question. I think this should, okay, this is the question. So I would like to, you guys should try once. So I'm giving you 2 to 3 minutes. So let me know if you are facing any difficulty.
So will these kind of questions will come in quiz too?
So see, I'm not going to say yes or no. So this is the one of the question this which has been asked in one PYQ, I think in some 23 May 23 or September 23. I can't recall the exact term number, but yeah.
So before finding projection, we will find the
Hmm.
covariance, right?
That is what you have to think. See, if it is asking projected variance, right? So
Yes.
to calculate the projected variance, what you need, I just gave you one hint here, right? So projected variance is what? That's the largest eigenvalue, right?
Yes.
Right?
First
That
we'll
is what you have to calculate the.
eigenvalue, eigenvector, and
That's
then
all.
covariance.
No, what is the point of calculating eigenvector? I don't know.
So
It is just asking what is the projected variance, right? How will you calculate the projected variance? Projected variance is nothing but lambda 1,
Eigenvalue.
right? Eigenvalue, right? So you have to calculate the eigenvalue of this matrix C. That's all. Understood?
okay.
Okay. These are the basic things you have to keep in your mind, right? So this doesn't involve too much things, but anyway. So just okay. So just try it out. I am giving you 2 to 3 minutes, and let me know what is the answer from your end.
Sir, I got one.
Okay, you got one. Okay, well, what about others? So let's say one,
Yeah, I got one too.
one.
Yes, sir. One.
Okay, one. Why? One is the eigenvalue, right?
Yes.
Sir,
Largest
I
Yes.
eigenvalue.
got three. Sir, two. I guess two is the larger eigenvalue.
It's a guess or you computed and you got two.
Rank is one.
No, no.
One eigenvalue.
I
Okay, two.
I got 0, 1, and 2. So two is the largest.
Okay, let's go with the two
Maybe
then.
maybe I'm wrong. I'm calculating again.
Anybody else? Those who are trying. Also, please let me know if you are not trying, so I will directly solve it. Yes, no? Should I solve it or? Okay,
Sir,
so
one.
silence means one. Huh? How did you solve, everybody? So
So
Sir,
diagonal
1
value should be
minus
1.
lambda.
It's 2 largest eigenvalue 2.
okay, well, so see, first of all, there is two method you can go with that. First is, okay, what is the way you have to calculate? You have to find the determinant of c minus lambda I, and you have to equate to 0, right? That is the way, and you will get this is 3 cross 3. You will get lambda 1, lambda 2, and lambda 3, and which one is the highest? That will be the projected variance, right? Is this clear?
Yes, sir.
Yes, sir.
Correct. So one way is we have to find the determinant of this part. So if you will calculate the determinant, so what is this? So I can write 1 minus lambda 1 1 1 1 minus lambda 1 1 1 1 minus lambda equal to 0.
Yes, sir.
Yes, sir.
How will you calculate determinant of this part? So this means 1 minus lambda. Let's take this. Then we have to ignore this first row, first column. So we have to find the determinant of this part. So it will be 1 minus lambda 1 1 1 minus lambda, then minus 1. So we have to ignore the second column, first row. So it will be 1 1 1 1 minus lambda, then plus 1 1 1 minus lambda 1 1 equal to 0. I hope this is okay to everybody. Now
Yes, sir.
what we will get from here, this is 1 minus lambda. So we are getting from here 1 minus lambda
Minus
square
lambda.
minus 1 minus 1 1 minus lambda minus 1 plus 1 times 1 minus 1 plus lambda. So far so good.
Yes, sir.
Yes, sir.
So here one will get cancel out, here one will get cancel out. So what are the things you are getting? So basically you are getting 1 minus lambda cube minus 1 minus lambda plus lambda equal to 0. Yes or no? So this
Yes, sir.
is, you are getting 1 minus lambda whole cube minus 1 plus lambda equal to 0.
Yes, sir.
This means we are getting
1 minus lambda cube minus 1 plus 3 lambda
minus 1 plus 3 lambda equal to
0.
0. Yes, what is
Sir, is the answer 3?
okay, let's see the 3, whether 3 is the answer or not. Okay, so once you will solve this, what is the things what are the things you will get here? So basically, how will you solve this?
Sir, lam. Yes, sir. Solve this. 3 will be answer.
Right? So
will be
from here
answer.
actually you will get lambda 1 equal to 3, lambda 2 equal to 0,
0.
and lambda 3 equal to 0.
0.
So projected variance
Equal
is
to
3.
0.
So another way is to look at this actually. So if you see the rank of this matrix, what is the rank of this matrix?
1.
1.
Right?
Sir.
Rank of this matrix is 1 because all rows are identical, right?
Yes.
So
Yes, sir.
So
see,
basically, I found both the values. It is 0 and 3.
so basically if I see, if rank is 1, that means one eigenvalue is equal to trace of this matrix,
Yes, sir.
right? And all other 0. So what is the trace of this matrix? That is 3.
3.
And
3, sir.
all other eigenvalues, so all other lambda i's will be equal to 0. So within a
0.
minute you can find out the answer. Okay, is the funda clear to everybody?
Okay, sir.
Yes, sir.
Okay, great. So let's try to solve this question.
Sir,
So
what if
first
the
of all,
ranks are
let's try.
what if the ranks are 2 and 3?
Okay, that is something you have to think about it. Okay, so see, if suppose see, if you are not able to recall the properties of this trace and all, right, so just go with the usual approach. Okay, You can go with the usual approach. Finally, you will get the same answer. It doesn't means if you are approaching in two ways, so you'll get two different answers. Okay, that is not the case. Okay, so let's try to solve this question. So this data set is given to you, and we want to project the above data set onto one dimensional space. So this is one of the PYQ actually. Okay, so you have to find this one dimensional space using principal component analysis. So first question is you have to compute the sample covariance matrix, right? So to compute the sample covariance matrix, what should be my first step?
Compute the mean, then subtract the mean from that.
Right, first of all,
Sir,
we have to center the data.
yes, sir.
Would you agree with me? Right, that is the part we have to do. So we have to center the data, and to center the data, what you will do? How will you start?
Calculate the mean.
So 2 plus 4 plus 6 by
Basically,
3.
we have to compute the mean vector and we have to subtract. Okay, so let's see.
Mean.
So first of all, let's try to
Yes.
calculate the mean vector. So
The
mean,
first one will be that, sir.
yeah, let's try to solve. So mean vector. So first step is mean vector. So how will you calculate the mean vector? It's nothing but 1 upon 3, and we have to add every. So basically, it will be 2 1 plus 4 3 plus 6 5. So divide by 3 because we are calculating mean. So it will be 1 by 3. So numerator part will be 6 for 12, and then 9. So this is 4 and 3, right? So this is the
4,
mean
3.
vector. Yes or no? And we have to calculate
Yes,
the
sir.
covariance matrix. So answer is A actually. Those who someone said, what's your good name?
Shawnee.
Those who said, yeah, Swami, yeah, correct. That's the correct answer. Let's try to cross verify. So what is the covariance matrix? So covariance matrix.
Sir, A is the answer.
Yeah, the A is the answer. So it's a 1 by n summation I is equal to 1 to n xi minus x bar into xi minus x bar transpose, right? So what we will do? We will go with stepwise. So just to avoid the thing. So what we will do? See, sometimes I use this small x1 and capital X1. Please, you have to make it as same, but it's x1 minus x bar. So what is the x1 minus x bar? What is the x1?
2, 1.
X1 is 2, and basically 2 1
2, 1
minus
minus
4
4,
3.
3.
So it will be minus 2,
Minus 2,
and
minus
then
2.
minus 2, right?
Minus 2.
And so later this implies, so what is the x1 minus x bar and x1 minus x bar transpose? That is something we have to calculate. Yes or no? So it
4,
will be
4, 4.
minus 2 minus 2, and transpose will be minus 2 minus 2. So what will be the answer?
4, 4, 4, 4.
8.
8?
Yeah.
No, I have calculated as x1 minus x bar. So this is 2 cross
Oh,
1, and this is 1 cross 2. So you'll get 2 cross 2. That is 4
4, 4,
minus 2
4,
minus 2,
4.
4 4 4. Everyone is okay with this?
Yes, sir.
Okay.
Yes,
Right?
sir.
So what is the second part? So
For second, everything
x2
will
minus
be
x bar.
0.
What is the x2 minus? Yeah, so this x2 is 4 3, right? So if you subtract x2 minus x bar, that is 0 0, and later x2 minus x bar into x2 minus x bar transpose will be 0 0 only, right? Basically it will be 0 0.
0, 0, 0, 0.
First will be well 0 0, then transpose is 0 0. See, sometimes people make mistake while computing this matrix. So if you are confusing, if you have any confusion regarding order of the matrix, so basically you can say this is 2 cross 1, right? This is 1 cross 2. So final matrix should be 2 cross 2, right? So it will be 0 0 0 0. So this is x2 minus x bar transfer. What is the x3 minus x bar? X3 is 6 5. So 6 5 minus 4 3, right? So basically it will be 6 5 minus 4 3. So it will be
2,
2.
2.
Correct. This will be 2 2. So later we have to calculate x3 minus x bar into x3 minus x bar transpose. So it will be 2 2 2 2 again 4 4.
4, 4, 4, 4.
Very good. So what we have to do, if you see, we have to do the summation till 3, right here, because it's we have 3 data set, right? So
Three
this will be,
data sets. Yes, sir.
so what will the covariance matter? It will be 1 upon 3 summation I is equal to 1 to 3 xi minus x bar into xi minus x
Minus
bar
X bar
transpose. So it will be
transpose.
1 upon 3 summation I is equal to 1 to 3. What is the, we have to
8,
add
8,
all these
8,
things, right? So basically it will be 4 4 4 4 plus 0
0,
0
0,
0
0,
0 plus 4
4, 4,
4
4, 4.
4 4 4. So let me remove this summation sign. So basically it will be in one bracket. So it will be 1 by 3, 8 8
8,
8
8, 8,
8.
8.
So answer is A. Okay, is this is the steps and everything is clear to everybody?
Yes, sir.
Yes, sir.
Okay, yeah, great. So now, if that is the case, so you have calculated the covariance matrix. Now you have to find the eigenvalues of this covariance matrix. So everybody, can you compute it, or should I proceed? What do you want? Feel free to say. I don't mind anything.
We will solve, sir.
I will solve. Okay. If that is the case,
No, sir.
then let's try
We will try
to find
first.
out the. Okay, okay, great, great. Then let's try for 2 to 3 minutes. Okay.
Sir,
I think it's A.
answer D. Option D.
Okay, I got one vote for A, one vote for D.
Sir, D.
D, sir, D.
Okay, so majority is going to D. It seems option D is
Yeah, yeah,
correct.
it's D. Sorry.
Yeah,
D, sir.
option D is correct. Okay, let's try to solve this. So I got some more. Well, so what we have to do, we have to find the determinant of C minus lambda I, and we have to equate it to 0, right? So what we will do, so first of all, it will be basically, or I can write determinant. Okay, first of all, what I can do, I can make it 8 by 3, and this is 8 by 3, 8 by 3, and 8 by 3, correct?
Sir,
So
here
what,
we also go with trace method.
trace method? See, you can go, yeah, because rank is 1 here, right? Because rows are identical, yes or no?
Yes, yes.
So you can go with the trace method. Yeah, that's a good catch. So let's try to do with the usual approach. So what it will be, I can write this as 8 by 3 minus lambda and 8 by 3. So it will be 8 by 3. Diagonal elements will be 8 by 3 minus lambda. It will be to equate to 0. Correct?
Yes, sir.
And we will get 8 by 3 minus lambda whole square minus 8 by 3 square
I mean
equal to,
64 by 9.
correct. So it will be 8 by 3 minus lambda whole square, that is 64 by 9. So this means what? So 8 by 3 minus lambda equal to, what is can I write? I can write plus minus 8 by 3.
8 by 3.
So basically it will be lambda will be 16 by 3, and lambda 1 will be 16 by 3,
0 and 0.
and lambda 2 will be 0. So that is the correct answer. Okay. If this is the clear, then let's come to the final part. See, somehow some of few of you have seen this answer A is correct, but we have to cross check. So if x1 tilde, x2 tilde, and x3 tilde are the projections of the data points onto the first principal component, then which among the following is correct? First of all, you have to find the u1, right? How will you compute the u1? Okay, before that, you need that u1 is what? That normalized eigenvector, right? Corresponding to 16 by 3. Yes or no?
Yes, sir.
So first of all, what you have to calculate? You have to calculate the eigenvectors. So everyone is following me, right? Are you getting what are the things I'm trying to say? Like
Yes, sir.
what are the
Yes,
things
sir.
we need to calculate for this
Can you
question? Okay.
scroll up?
Yes. You do you any doubt?
Yeah,
Yeah.
scroll up.
Yeah. Okay.
Please, can
Any
you please
doubt?
show the last question of
No,
this
no,
part?
I
Like,
accidentally touched it.
Okay.
Yeah. This.
yeah. So how is this being calculated? Can you please explain me again?
Yeah. We have to calculate. We have to find out.
Oh, so
See,
you
I told you. So the final thing, this x1 tilde, how we have to calculate? This is kind of transform data, right? So xi tilde is nothing but xi transpose, xi dash transpose. This xi dash is nothing but I'm talking about xi minus x bar, right? This is centralized version actually. Well, so I'm talking about like this. So this because I have no give you the notation. So this u1 is the normalized eigenvector, first eigenvector corresponding to the largest eigenvalue, plus x bar because we have centralized, right? We have subtracted the mean. So to compute this x1 tilde, we need to, first of all, we need to compute this u1, right? To compute u1, what we need? We need to calculate the eigenvector of C. Yes or no? So there are two corresponding eigenvalues, 16 by 3 and 0. So since we are going with the one dimensional PC, so no need to spend time on calculating eigenvalues for lambda second eigen like lambda 2 equal to 0. We can go with the lambda 1 equal to 16 by 3 only. Okay. So what is the
Sir,
first step we have to calculate? So we have to calculate. Yes. Yeah. Go ahead.
no, sir, you complete then.
Yeah. Please.
Eigenvector is 1 by root 5, 1, 2, 2, 1.
I
Like,
don't know. I need to
sorry,
calculate
both
actually.
eigenvector. Okay.
I need to calculate.
Okay.
Yeah,
So
eigenvector.
can you explain the question?
See what question says. So question says we have to find the projections of the data points onto the first principal component. How will you compute the first principal component? So first principal components is corresponding to the largest eigenvalue,
Highest
right?
eigenvalue, yes.
Highest eigenvalues. Yeah. So that is something we have to do. So if you see the steps here, so what we have to do? We did mean vector, we did covariance matrix, we did this eigenvalues. Now to find this transformed data, right? Basically this projected part, right? For this transformed data, we need this projection. Actually, this projection part it is asking. So, well, so to calculate this part, what we need? We need the eigenvalue. First of all, we need eigenvalues, right? And then later we will normalize it and we will use this. So u1 is the normalized vector. Okay. So let's compute the eigenvector corresponding to lambda 1 equal to 16 by 3. So this will be, what is the C? C was 1 by 3, 8, 8 if I'm not wrong, right? It was 1 by 3, 8, 8, 8, 8 minus, what is the lambda 1? Lambda 1 is 16 by 3. What is the, it's the 1, 0, 0, sorry, 1. So no one corrected me. So basically what we have to do, it will be, we have to compute the eigenvector. What we have to do, we have to do C minus lambda I. Let's say some V1 is there. Okay. Is this clear? We have to find the
Yes, sir.
first eigenvector corresponding to lambda 1 equal to 3, 16 by 3. So this is something, it will be, let me write here actually. So I hope I should have, we have one more page. So here it will be 1 by 3, 8, 8, 8, 8 minus lambda 1 is 16 by 3, 1, 0, 0, 1. So this is C minus lambda 1 I. What is the V? It's let's say V1 and V2. So let's make it V. Okay, anything you can take. So usually we need one thing, right? One vector. That's not a problem. So it's equal to 0, 0, right? So let what we can do next step. So what else I can do? So basically you can see here 1 by 3 I can take overall common, right? So what you will get? I will get 8, 8, 8, 8 minus 16, 0, 0, 16. Yes or no? Would you agree with me?
Yes, sir.
And then finally what we will get? So if you subtract, so 8 minus 16 I will get minus 8.
Great.
8 minus 0, 8, and then 8 minus 8, and here it will be v1 v2 equal to 0, 0. Correct? What should be the next step? So see, if this is the case, what else can I write? Can I write this as the same as minus 8, 8, 8 minus 8, v1 v2 equal to 0 0,
Sir, we
right?
can basically write that V1 equals minus V2 or minus V1
Yes.
equals V2 directly.
Yeah, we can. So here what, okay, so I'm just going step by step so that it should be clear to everybody, so that's the way. So this is, I can write minus 8 v1 plus 8 v2 equal to 0. This is the equation we'll get. This means I can write 8 v1 is equal to 8 v2. This means I can write v1 is equal to v2 or not.
Yes, sir.
Yes or no?
Yes,
So
sir.
this means
Yes.
what will be your eigenvector here? So eigenvector v will be, basically what will be your eigenvector? I can write 1 1. Yes or no?
Yes.
Now what will the normalized eigenvector? So normalized part, so normalized means, so normalize, so to normalize what you will do, you need norm square of this v, right? Basically norm of this v, so it will be square root of 1 square plus 1 square, it will be square root of 2. So what will be u1? So u1 is this normalized vector. So this normalized vector will be what? It will be 1 upon root 2 1 1. Is this clear now?
Yes, sir.
So
Yes.
there is no need to go with for lambda 2 equal to 0, right? It is because it is not, it's not asking, right, to us. So what we will do, we will quickly compute with the compute for this, the projection part. So what is that? So what will be xi tilde? What should I write? It's a xi dash transpose into u1 into u1 plus x bar, right? Yes, no,
Yes, sir.
right?
Yes, sir. Yes, sir.
So what is this xi this xi dash? So this xi dash, I mean this part, right? Xi dash, this is xi dash transpose. This xi dash means I'm talking about x minus xi x1 xi minus x bar. Is the notations clear to everybody? So this means I'm trying to say here c is equal to 1 upon n summation I is equal to 1 to n xi dash transpose. So where this xi dash means xi minus x bar. Okay, is this clear now? So what is the xi dash here? So basically, how many xi's we have?
3.
Right,
3.
3. So first of all, this is the general. So what will be x1 tilde? So it will be x1 dash transpose into u1 into u1 plus x bar. So why we are adding x bar? Because we have subtracted initially, right? Now, so what is the x1 dash? So x1 dash means I'm saying x1 minus x bar. So what is the x1 minus x bar? So x1 minus x bar we computed as a
Minus 2, minus 2.
minus 2 minus 2. So it will be basically it will be minus 2 into u1. So what is the u1? U1 is
1 by root 2, 1,
1 by
1.
root
1 1.
1 by root 2
1 1.
1 1. So this is this part, right? Yes
Yes,
or
sir.
no?
Yes, sir.
Okay, should we
Yes.
compute separately? Let's compute separately, right? So for this actually, so let's focus on this part first. Okay, let's focus on this part. So let's compute this part. So x1, what is this? What is the meaning of this x1 tilde transpose u1? What does this mean?
Dot product.
No, what product is okay. I'm talking about in terms of
Projection,
EC.
projection on.
It's a
X on
projection,
minus.
right? Projection of x1 dash on u1,
Yes.
right? So basically it will be okay. So this is x1 minus x bar is what? It's a minus 2 and u1 is 1 upon square root of 2 1 1. So what will be the answer for this? Let's make it equation number 1. So what is the answer for this? It will be 1 upon root 2. It's a minus 2
Minus 2,
plus
minus 2,
minus
minus 2,
2.
minus 2.
So minus 2 root 2. Would you agree with me? Right?
Yes.
Are you
Yes,
getting
sir.
my point?
Yes, sir.
Yeah. So the next is what we have to compute next part. So we have to compute x1 dash transpose u1 into u1. So minus 2 root 2. And what is the u1? u1 is 1 upon root 2, 1, 1. So this root 2 will get cancelled out. What is the things you will get?
So -2, -2.
-2.
Right, minus 2. So finally from equation 1 what will be from equation 1 what will be my x1 tilde? See, I think few of you might be getting bored. I'm doing very basic steps, but I think it's necessary for everybody to understand what is the algorithm behind it. So what is the mean was 4 3, right? So it was 4 3. So what we will get? We'll get
2 and
2 1. So x1 dash is 2 and 1. So let's see in the option. I think just because this one is, you can say this is the correct, right? Because no option is repeating for x1 tilde, right? If x1 tilde is 2 1 is for other options, then you need to cross check for x2 and x3. Do I need to solve for x2 x3, or is this okay to everybody? You can go with this approach. Yes,
same
no?
method. Okay.
Same
Yes,
method,
sir.
right? So basically to compute the x2 tilde, what you have to do? So x2 tilde, it will be xi dash transpose u1 into u1 plus x bar.
So
That
X2
is
and X3 will be same.
sorry.
X2 and
Yeah.
X3 will be same.
Why? No,
I'm
it's
asking.
different.
Then we have to
So
find the
yeah, you
eigen.
have to find, you have to follow this
X2.
approach.
Yes,
See,
yes, sir.
what do you have to do? Here it will be x2. See, here this is, I'm talking about x2, so it will be x2 dash transpose, right? Then what you have to do? You have to compute the x2 dash transpose into u1. What is the x2 dash? Basically x2 dash is nothing but x2 minus x bar transpose u1. So you have to compute this part. What is the x2 minus x bar? I think it was 0 0, right? Correct?
Yes, sir.
0 0,
Yes,
1
sir.
upon root 2, 1 1. So if you see, it will be 1 upon root 2,
I'm right.
0 0 only, correct?
Yes.
And this whole part will be 0. So x2 tilde will be 0 plus what is the x bar? X bar was 4 and 3, right? So your x2 tilde will be 4 3. So you can see this x2 tilde is 4 3. Similarly, you can compute for x3. Is this clear to everybody?
Yeah,
Sir,
sir, understood.
Yes, sir.
can we do like that without all the calculation we do in the one shot, like this? This crop.
See, you
This,
can do everything in one shot. You can substitute everything here and this
yes,
u1 and
yes,
plus
that's
xn.
it.
You can do, that's not a problem at all. Just to avoid confusion, right? Sometimes you will get confused whether what are the order and all. To avoid the confusion, I'm just separating each term so that it should be clear what is the base like backend algorithm going on, right? That's all I want. I see. If you say I will do right now within a line, that's not a problem for me. Okay. So I'm just it should be clear to everybody. That's what I'm doing stepwise. Okay.
Sir,
Yes, yes.
Yeah.
will the
Sir,
answer
can I?
change with respect to eigenvector we are choosing? You
No. So we have to check. We have to go with 16 by 3 only here.
I mean
See.
eigenvector, not the value vector.
Yeah, eigenvector. Yeah. So you can choose 2 here. That's not a problem.
I
2
can
2.
even
But the
choose.
standard way is choose 1 actually. So you can go with 1. That's not okay.
Okay.
So eigenvector. Huh?
Will the answer change if I choose different eigenvector?
Can you cross check? See,
Yeah.
it will be 2 2, right? It will be 2 2, right? So this, it will be basically, you can cross check here. So it will be minus 2, not minus 2 root 2. So here it will be
We can just choose
2 2. What?
-1, right? Instead of 2 2.
So,
Sorry, you are saying minus 1.
Yeah, yeah. Because if we are choosing 2 2, then we have to divide by the norm again.
Yeah, correct. Okay, if you are saying you want to go with -1, okay,
Yeah.
let's go with -1. If you are going with -1, so this will be plus 2 root 2.
Yeah, correct.
right? It will be plus 2 root 2,
Yeah.
and here it will be minus 1 minus 1. So again you will get minus 2 minus 2. We are getting same answer.
Okay. Okay.
Are you getting what I'm trying to say?
Yes.
If
Yes.
you are if you are going with the 2 and 2, so this will be 2, right? Norm square
Yeah.
root of that norm part,
Correct.
right?
Yeah.
Then some 2 will get cancelled, or that you'll get fine.
Okay.
That's
Okay.
it. Okay.
Right. Yeah.
Okay. Yeah. Okay. Well, so if this is the clear, then I would like to everybody try this out. This question. So because we did this question, so please solve this. Okay, so if you don't want to try, do let me know, so I don't mind. So please try to
No,
be
sir. Give
honest.
us 3-4 minutes. If we cannot,
Okay,
then
all right, yeah, no problem, no problem. Yeah, please try to solve.
Sir, X3 tilde for the previous question is 6, 5.
X3 theta, you are saying 6 5, right? Yeah, that is the correct answer actually. 6 5 should be the answer. Yeah,
Okay, sir.
that is the
Yes.
correct. Yeah, yeah, great. I'm glad you have tried.
Sir, is it option B?
Let's see, I don't know.
Okay. I'm getting B.
Like, okay, you are getting B, so I got one vote for option number B. Let's wait for others.
I need
sir,
option
option
B.
B.
Okay, two vote for
Sir,
option
Sir,
B.
option
option
B.
B. Option B.
Okay, option B. Even I don't have answer. I need to calculate it. Yeah, well. So let's see if I think majority is option B. So I hope this is the correct. Okay, so let's cross check. We have to calculate the sample covariance, right? So to calculate the sample covariance, what is the formula for that? It's a 1 upon n. It will be summation I is equal to 1 to n, and we will take with general xi minus x bar, xi minus x bar transpose.
Transpose.
So it will be 1 upon n, summation I is equal to 1 to n. I'm just denoting xi dash and xi dash transpose. Okay. Now, well, so first of all, what we have to do, we have to compute the x bar, right? So x bar is what? Mean vector, right? So this will be 1 upon 4, and within a bracket, so it will be 4 1 plus 2 3 plus 5 4 plus 1 0, right? So it will be 1 upon 4, and it will be 4 6 11 and 12, and this will be 8, right? So finally I will get 3 and 2. So this is my mean vector. It's not 0. That means we have to subtract the mean. So I will go again that usual approach. So x1 minus x bar, I'm writing this as a quickly, x1 minus x bar transpose. Okay, so what will be x1 minus x bar? So x1 is this 4 1, and x bar is 3 2. So what will be 4 1 minus 3 2? It's a 1, minus
Just
1,
one
right?
compound.
So it will be 1 minus 1 and 1 minus 1 transpose. So I'm skipping some steps as I did in the previous question. Is this okay to everybody? Are you with me?
Yes, sir.
Yes,
Okay,
sir.
great. So this will be I will get 2 cross 2 matrix, right? So this will be 1 and then minus
Minus
1,
1,
then
minus
minus
1,
1
plus
and then plus 1. Very good. Next, I have to calculate x2 minus x bar into x2 minus x bar transpose. So what is the x2? x2 is 2, 3, x bar is 3, 2. So it will be minus 1 and 1. Am I right?
yes,
So it will be minus 1, 1, and it's sorry, I shouldn't write t here because I already in transposed version. So minus 1 and 1. So it will be 1, minus 1, minus 1, and 1. Correct? I hope I'm clear.
Yes, sir.
yes.
Now, what is the x3 minus x bar and x3 minus x bar transpose? So x3 is 5, 4 minus 3, 2. So it will be 2, 2.
2, 2.
Correct? So it will be 2, 2, and it will be 2, 2. So it will be simply 4,
4, 4.
4, 4, 4. Correct? So this next is x4 minus x bar and x4 minus x bar transpose. What is the x4? x4 I have 1, 0, 3, 2. So it will be minus 2, minus 2. Am I right? So it will be minus 2, minus 2, minus 2, minus 2. It will be 4, 4, 4, 4. Correct? Now, what is the next thing we have to do to compute the covariance matrix? It will be C is equal to 1 upon 4, summation I is equal to 1 to 4, xi minus x bar into xi minus x bar transpose. This means, so 1 upon 4, we have to do x1 minus x bar into x1 minus x bar transpose plus x2 minus x bar, x2 minus x bar transpose plus x3 minus x bar, x3 minus x bar transpose plus x4 minus x bar, x4 minus x bar transpose. This is the meaning. So what we have to do, we have to add all these things. So it will be
Yes.
1 upon 4. It's a big square bracket. So it will be 1 minus 1 minus 1 1 plus 1 minus 1 minus 1 1 plus 4 4 4 4 4 4 4 4. So if you calculate it will be 8 plus 2, that is 10, and minus 2, that is 6. So basically it will be 1 by 4, 10, 6, and this is
610.
6, 10. Okay, am I right?
Yes, sir.
Yeah, so yeah, option B is the correct. Okay. Well, so what is the next thing? We have to find out what is the principal direction that is chosen for performing PCA. So that means what you have to calculate for this part? Can you tell me?
Eigenvectors.
U1.
Eigenvectors.
Sir, you have to find the U value for this.
U value in?
So U1 is the first principal component, right, sir?
Yeah, right. So that is, but we have to, that should be normalized
Normalized.
form. That's what I want to.
So
U
the
value for the
normalized
largest eigenvector.
eigenvector.
Correct. So now, okay, should I solve it or you want to solve it?
So first we have to find eigenvalues, no?
Yeah,
Give
that's
us
what.
2
So to
minutes.
compute that eigenvectors, to compute that u1, you need the lambda one, right? Largest. So
Yes, sir.
then first you have to calculate the eigenvalues, and then you have to see something. Some steps would be clear in your mind, so that what you can keep in your mind, you can keep in your mind these steps, right? If you are going with this step, you will be able to compute it. Anyway, so let's. Okay, should I proceed? So what I have to do?
Sir, give us 2 minutes.
Okay, all right. If you want, that's a good thing. Then if you want to try, yeah. Yeah, go ahead,
I
please. Yeah.
got option A.
Okay, option A. If you are saying, have you calculated or it's random?
I calculated it.
Okay.
Sir, principal direction means that normalized
U1,
eigenvector.
U1. Yeah, that's principal direction where you are projecting the things actually.
Okay, sir.
whoever solve with lambda is coming 4 and 1, right?
Yes.
Yes, correct.
Yes,
Okay.
lambda 4 and 1. Okay, so you have to go with 4, right?
4.
Yeah,
We have
very
to,
good.
yes.
And okay, within a minute, if I will ask what is the projected variance, what should be your answer?
4.
So
Four.
no, it should be
4
one
is
one.
4.
Sir,
One,
option no, no, no. My question is what is
4.
the projected variance?
4, sir. 4.
4.
4.
Yeah, that is 4, right? Yeah, well, yeah, please proceed. Yeah. Option 2. Option 2.
Option 2 is correct,
Okay, I
sir.
got 2
B.
vote for option number 2. Let's see. So I will wait for 2 more minutes, then I will start the solution part.
Sir, option B.
Okay, shall I proceed? Yes, no?
Yes, sir. Please
Yes, sir.
proceed.
Yes,
Okay,
please.
so basically we need to calculate the u1, right? That is the normalized eigenvector corresponding to largest eigen value. So I need to calculate the what is the c we got? It's 1 by 4, 10, 6, right? So basically it's a 10 by 4, 6 by 4, 6 by 4, and 10 by 4. So first of all, I need to calculate the determinant of c minus lambda I, and I have to equate to 0 to compute the eigenvectors. Sorry, eigenvalues. So what we have to do? So it will be, I can write 10 by 4 minus lambda, 6 by 4, 6 by 4, and 10 by 4 minus lambda. Is everyone is okay with these steps?
Yes.
Yes, sir.
Okay. And so this
Sir,
is
can we
actually
reduce?
right,
Sir, is it
determinant.
not better to simplify 10 by 4 and 6 by 4 to 5 by 2
Yeah,
and 3 by 2?
we can. I'm just going with this just not to do calculation actually. So you
Okay,
can.
sir.
That's not a problem at all. Even you can go with the 10 6 and let's say you can go with like this 1 by 4 and a, right? You can easily find out the eigenvalues of a, and then later you can divide by 4 to all the eigenvalues. At the end answer will be same. Understood? So you can go with either way. That's not a problem at all. I'm just going with this not to do too much the things. So well, so what is this thing? So it will determinant will be 10 by 4 minus lambda square minus 6 by 4 square equal to 0, correct? So it will be 10 by 4 minus lambda whole square, that is 36 by 24. Sorry, 16. Would you agree with me?
Yes, sir.
Now, can I write this 10 by 4 minus lambda equal to plus minus 6 by 4?
4.
Then this lambda 1 will be 16 by 4, that is 4. And lambda 2 will be 4 by 4, that is 1. So we have to go with lambda 1 equal to 4, which is the largest eigenvalue, right? So now what I have to do, I need to, I have, yeah, we have one page. So what I have to do, I have to calculate this c minus lambda 1 I. Let's say it's v equal to 0, right? Then what is the C? C is again well, what is the C?
Vector,
C was
the matrix.
1/4.
1 by
Sir, 1
4,
by
10,
4
6, 6, 10.
6s.
yeah.
Yes.
So it's
by 4, 10,
10 by 4 minus
4.
yeah, minus 4, right?
No, not no, 6.
Okay,
Yes.
okay. Let's go. Let's do.
Take 4 na.
So
Then we
basically,
can.
this is C minus 4 into I, right?
Yes, sir.
Correct. So basically, what is a C? C is nothing but basically it's
10, 6,
no,
6.
this is I shouldn't write like this. So no one is correcting me. I don't know why. So this would be in matrix form, right? It's not
Yes, sir.
written here. So this is the 10 by 4 minus 4, and then this is 6 by 4, and this is 6 by 4, and this is 10 by 4 minus 4, and this is something I can write as a
Minus 6 by 4.
V1, V2, and 0, 0, right? So what is this is minus 6 by 4, right?
Yes, sir.
Minus 6 or
Yes, sir.
6?
No, minus 6, sir.
Minus 6, right?
Minus 6/4, 6/4.
Yeah. So minus 6 by 4, this will be 6 by 4, this will be 6 by 4, this is minus 6 by 4, and this is V1, V2 equal to 0, 0. So from here, I will get minus 6 by 4 V1 equal to, sorry, plus 6 by 4. Yeah, this is 0. Then this means basically I can say V1 equal to V2. So what is the eigenvector here? So eigenvector will be 1, 1. And what is the normalized eigenvector? So normalized eigenvector,
1 by root 2.
basically
1 by root 2.
I'm talking about U1 is equal to 1 by root 2, 1, 1.
Yes.
So that is the answer. So B is
So
the correct.
eigenvectors we can take minus one also, right?
Yeah, you can take minus 1 and minus 1, but there is no option in minus 1, 1, minus 1, minus 1, right? Okay, clear?
Yes, sir.
Yes, sir.
Okay, well, great.
Yes, sir.
So
Yes, sir.
now the final step. If x1 tilde, x2 tilde, x3 tilde, x4 tilde are the projections of the data points onto the first principal component, then which of the among following is correct? So let me do it. So what you can do, you can help me. Basically, you can tell me what I have to do. So basically, in general, what I need to write. So xi tilde is what? Xi dash
Dash
transpose
transpose U1 into U1
U1
plus
plus
X bar.
X bar. What is the meaning of Xi dash? I'm saying it's a Xi minus X bar.
Minus X bar.
Correct?
Yes, sir.
Well,
Yes, sir.
now what is the things I have to calculate? X1 tilde. So X1 tilde will be X1 dash transpose U1 into U1 plus X bar. So what is the X1 dash transpose? Basically, I'm saying Xi minus X bar transpose. What is the Xi minus X bar?
So
1 minus 1.
1 minus 1, right? So basically, it will be 1 minus 1. What is the U1? U1 is 1 upon root 2. I'm writing here, and it's a 1, 1. So this is one bracket for this. And what is the usual U1? Let me write U1 plus X bar just to avoid confusion. So it will be 1 upon root 2, and it will be 1 into 1 minus 1. That is 0, right?
Yes, sir. Yes.
Right? See, 1 into 1 minus 1 minus 1, that is 0, right?
Yes, sir.
Correct? So it will be 0 plus X bar. X bar was, I think,
Only thing is X bar.
So 3, 2.
But X tilde is the data. The X tilde. What?
so X1 tilde is 3, 2. So you can see D is correct, right? Within a minute you can see, because
sir.
see, if so, let's say in C also there is 3, 2, you have to cross check for other option, but we'll do for other so that it should be clear how to proceed. So now what is the X2 tilde? How I should proceed? So
Sir.
X2, yeah.
So what is the notation for centered data point?
The same thing, right? So here it will be 0. That's all.
Okay, sir.
And later you are adding 0, it will give you the same answer. So this is the general equation. You can go with this actually, right? So if you have already sent a data point, if you are adding x bar finally in the transformed version, it doesn't affect the result. Okay. Well, this is the part. So what is the x2 dash was? Again 1 minus 1, right? Same thing, if I'm not wrong. Can you cross check?
No, it was
So
minus
minus 1,
1.
1.
It was
Minus
minus
1. Okay. Minus 1 and 1. So it will be, what is the u1? U1 is 1, 1, right? And into u1 plus x bar. So this will be again 0, right? 0 into u1 plus x bar. This is same as x bar, which is 3, 2. So this x2 tilde should be same as 3, 2. That means you can see. Right? Is it clear? Let's do for this question. Let's do for other. So what is the x3 tilde? Tell me, what should I write here? What should be equation?
So it is
X3
2, 2.
Yeah, x3
dash transpose
Dash
transpose
minus
u1 into u1 plus x bar.
plus x
plus
bar.
x bar. Yeah, what is the x3 dash means? It's nothing but x3 minus x bar. Well,
Yes,
so
sir.
what is the x3 dash? It was 2, 2, right?
Yes, sir.
Yes, sir.
So see, don't confuse this dash with transpose. Okay, this is just a different. Even you can write like this. So x3
So
minus.
we can
You know,
see centered. So say C x3 C. We can write C. No.
yeah. You can
So
go.
x
You
dash
can go with.
x3 dash is centered x3, right, sir?
Yeah, it's a centered. So since I have used dash only, so please be clear with this. Now, so what was the x3 dash?
2, 2, 2, 2.
2, 2, right? So if that was the 2, 2, so what should I write here? So it will be 2, 2, and u1 is 1 upon root 2. I'm writing here, and it was 1, 1. This u1, let's keep it separate right now. So it will be 1 upon root 2, and it will be 2 plus 2, that is 4, correct?
Yes, sir.
So that is 4 by root 2, that is 2 root 2.
Yes, sir.
Yes, sir.
So I'm writing like this. So this is 4 by root 2, and what is this u1? U1 plus x bar. So now let's simplify. So this will be 2 root 2, and u1 is 1 upon root 2, 1, 1, and x bar is 3, 2.
3, 2.
So this 2 root 2, 2 root 2 will get cancelled out. It will be 2, 2, and
Yes.
3, 2. So it will be 5.
5.
4.
So x3 tilde is 5, 4. So it should be 5, 4. Yeah, very good. And then finally it should be 1, 0. I think x4. So okay, tell me, what should I write for x4 tilde? Tell me the equation first.
Sir,
X4 dash transpose
transport
U1 into U1 plus
Plus
X bar.
Very good. So this x4 tilde is what? X4 minus x bar. So I think it was minus 2, right? If I'm
Yes, sir.
Yes, sir.
So it will be 1 upon root 2 for u1. It's a minus 2, it's a 1, 1 into u1 plus x bar. And what is this? So it will be 1 upon root 2, minus 2, it will be minus 4 into u1 plus x bar. So this will be minus 2 root 2, and u1 is 1 upon root 2, 1, 1, and it is 3, 2. So this will be minus 2 plus 3, 2. So it will be 1, 0. So finally we got x4 tilde as 1, 0. So you can see x4 tilde as. So this option D is the correct option. Is the idea clear to everybody?
Yes, sir.
Yes,
Yes, sir.
no.
Yes.
Is the steps and all, how to apply the notations, formula and all?
Yes, sir.
Present x dash, can we take the transpose of the data set and eliminate the x bar adding part? What do you mean by this? See, this is the general equation. That's what I'm trying to say. See, if you are taking in this part, what you can substitute? You can substitute this one as a xi minus x bar transpose, right? So this is in transpose. This is centralized version, right? u1, this is you're finding projection of this on u1, right? Plus I'm adding x bar because I have subtracted. If there is no x bar, it is already centralized version, so it will be automatically xi transpose u1 into u1, because if x bar is 0. Okay,
If
so
we already centralize in the starting, then no need to add this X bar na in the later.
no. So you can go with this actually. That's not a problem. So see why I'm saying. So suppose you are going with this formula. If your x bar is 0, so it will be 0, and here it will be 0, and finally you will get this form. Right? At the end, answer will be same.
Sir, we will be
Okay.
given centralized data only, na, in the exam.
Yeah, you will be given the centralized data. But
So
for a
then X
second, you
bar
can
will come
cross
as
check.
0.
See, for this kind of a small data set, within a second minute you can check, right, whether it's centralized or not. But it will be given to you. Okay, it's clear.
Yes, sir. In that case, we need not add X bar because X bar will be 0 if it is already
Yeah, x bar will
centralized.
be 0. Yeah, yeah. Okay, so so now we are done with the basically week 7. So major week 7 concept is this you know PCA only. Now I will quickly give you the formula of week 8, and we'll try to understand how to go with how to try to solve these things. Okay. So in week 8, actually, what is the key thing we need to study? What are the things you have done? That is called optimization, right?
Yes,
So we
yes, sir.
started.
Constant
Sorry.
and the constant part.
Yeah, so there were two things, right? Constraint optimization, unconstrained. So see, usually in week 8, so usually we focus on unconstrained. Okay, so for the constraint, you may ask some condition. I mean, how to formalize the suppose some story is given to you, and how to formalize in mathematical way. So that is something we have seen already. So what is the optimization? So optimization is basically is about finding the best solution of a function, right? So optimization is about finding a best solution of a function. So what do you mean by best solution? So for example, let's say uh,
Sir,
you
least
want to
error.
choose the best classifier. So best classifier means basically
Least
so
error. Error should
least
be as soon
yeah.
as least as least.
So this best means I'm saying least error or or maximum reward. Okay. So we want to try to minimize this part. So we have seen that no cow story, how what should be the minimum distance from cow to grass, and if you consider lots of constraint and all. So basically what we okay. So if you see in general, one form,
Sir, I think
one
your
form.
voice is.
Yes, sir. Voice is not recording.
Voice is cracking.
Yeah.
So,
So there
No,
is a
sir.
minimum error.
Hello.
Hello, can you hear me now?
Yes, sir.
Yes, sir.
There was some network issue. So, is my voice clear, right?
Yes, sir.
Yes, sir.
Okay, well, yeah. So please do let me know if at any step you are facing any difficulty. So, okay, so we will start from week 8. Okay. Okay. Can you see my screen now?
Yes, sir.
Okay. Well, so in machine learning context, so this optimization plays a very important role. So we will see two kind of optimization part, right? So say this, so there are two kind of things. So constraint optimization and unconstrained. So in week 8, so we are mainly focusing on unconstrained optimization, correct? So first of all, what is the general general form of optimization? I mean, this constraint optimization, if any one of you can tell me.
The minimizing f of x
Okay.
on x,
Hmm.
and we have g of x and h of x, where g of x is less than 0 and h of x is equals to 0. These
Hmm.
are the equality and inequality constraints. And we
Okay.
have to find that value of x which will minimize the f of x, which is called the objective function.
Yeah, that is called the objective functions, correct? So basically, so what is the general form? If you, I will write here. So general form is nothing but it's
X square.
we want to minimize f of x, and
Yes.
x in, let's say, in rd, right? It's a d dimensional, it's a d dimensional. And what is this f of x? It's called my objective function. So in general, so let's say there are some constraints called gix, which is called inequality constraint. For all, let's say there are k inequality constraint, and then hj of x is equal to 0. This is called equality constraint for all j is equal to 1 to some, let's say, capital.
So you are on low battery, sir.
Oh, yeah, yeah. Thanks, thanks. Okay, so let me connect with charging point. Yeah, I will connect. Yeah. So this is the basically this is called the constraint optimization, right? So we will discuss about this more in week 9, but there is something we can something we can make it like if some story is given to you, so how to formalize this constraint optimization. Okay, so we have seen some story, so would you like to see that story again, or is it okay to everybody?
Cow story.
Cow story is okay, we can go with any other story.
Yes, sir. Any other, it would be fine.
Okay, let me see. So that should be in week 8. Let me open some practice assignment. I think last time we did the same thing. Okay, let's see this question. Okay, so a manufacturing plant produces two products M and N, and the maximum production capacity is 700 for total production. So this is the maximum capacity. At least 270 units must be produced every day, and machine hours consumption per unit is 6 hours for M and 5 hours for N. And what is the next statement? At least 1100 machine hours must be used daily. So manufacturing cost is 25 rupees for machine M and 35 rupees for N. So what is the X1? So X1 represents the number of units M produced per day, and X2 is the number of units produced per day. So what will be your objective function? You would
Minimizing
like
the
to minimize your
manufacturing
cost
cost.
or maximize your
Yeah,
cost?
minimize.
Minimize, right? So which option should be correct? First or second? I mean, which first, second, third, fourth? Which one is correct?
Third.
Why third? Because number of
35
units,
x2.
right? Number of units produced per day, right? X1 represents for M. So
Yes.
and for M, what is the cost for each?
25
It's a
for M,
25.
35 for N.
Yeah. So this should be your correct option. Let's cross check. So this should be your correct option. Where it went? Where it went? Yeah, this is your correct option. Now, what is the next? So what is the constraint due to maximum production capacity? What is the maximum production capacity? It's a
So if
700.
a maximum, it means less than or equal to 700.
Okay, what should be less than or equal to 700 or greater or equal to 700?
So less than, because it is max.
Right? It shouldn't exceed the 700, right?
Yes.
So x1 plus x2, that one condition is this maximum production should be less than or
Less
equal to
than or
700.
equal to it.
What about this? The constraint due to minimum production capacity. Let me go to the question. Minimum production capacity. Minimum production capacity.
So greater
Greater
than
than
equal
equal
to
to 270.
Very good. It is said because
because
at
it is
least.
at least.
Yeah. So now
At
this is
most could be anything.
correct. What is the constraint due to machine hours? Let me go to the question. What is the constraint due to machine hour?
Greater than equal to 1100.
Yeah, what is that grade? Just not go with the just don't go with the inequality. And what should be?
6x1 plus
Hmm?
5x2
Yeah,
greater
so
than
it's saying
equal to
consumption, right? Machine consumption. So what is the 6 hour for M? That is 6x1 plus 5x2. That should be greater or equal to 1100. Yes or
1100.
no?
Yes,
Right?
sir.
Okay. So you can see how some story you can formalize, and you can find out what is your, well, what is the objective function, and then you can proceed with that. Anyway, so this is, we will discuss about this more in week 9. So but what about unconstrained optimization? So in unconstrained optimization, actually, so this is optimization. So we saw, right? So we can start with, let's say my objective function is x minus 5 p square, and I can find the first derivative, and I can equate to 0, and I can say what is the minimum of this function. But in general, it's very difficult to, if you have some complicated function, so it's very difficult to go with the derivative and do these steps. Yes or no? Right? Find the solution. I mean, you can find out the derivative. If I have function, let's say some 5x4 plus 4x cube, and I want to minimize this over x in real, and then let's say 3x square and some 7x plus 8, so something. So you can find out derivative, right? But
Yes.
if you will find the derivative, it will be
20x cube,
20x3 and plus
12x
12x
square.
square plus 6x plus 7. But it's very difficult to find the that point, right? So what is the general approach? So we saw the approach is the to start with the some update, right? So I mean some initial guess is given to you. You can start with the update rule. So what update rule says? So this suppose xt plus 1 equal to xt plus we saw some direction, right? So we saw this we are suppose starting from xt. Suppose starting from x, you are starting from x naught actually for t is equal to 0 1 and 2 so on, and we saw we want to move in some direction, and in open session we see, we already we have seen this d is the we need this good direction, right? And that good direction was minus f dash x, correct? But we didn't stop here, because in that case what happened, so we were kind of oscillating, right? We were not able to reach to the minima, yes or no? What uh, to the minima, right, or optimum. So what was the case? So problem was not with the direction, right? So problem was with the amount of direction. What should be step size so that you can reach minima, right? So what was the solution we got? So we got it should be xt plus 1 equal to xt plus eta minus f dash x. So this eta is called step size, or sometimes we call this as a learning rate. Yes or no? And this eta we did for some eta we did we cross check for 1 upon 2 raised power t, but we didn't find is good eta. So we found out another which is eta is equal to 1 upon t plus 1. So finally what we decided xt plus 1 equal to xt minus or plus 1 upon t plus 1 into minus f dash xt. Is this clear? So basically what we are doing
Yes, sir.
xt minus 1 upon t plus 1, this is step size, and this is
F dash
f
of
dash
x.
xt.
F dash
So
of
this
x.
is in one dimensional. So if you have two dimensional, or if you have to apply this gradient descent algorithm in 2D, or well, in 3D, so what should be your update actually? So my formula will be, yeah, go ahead,
Negative
tell me.
of nebular.
F of
Yeah, no one.
f of
So
x1
basically
Sorry,
is
I
sir,
can
what's
write
the question?
xt plus 1, let's say vector, and
equal
this
to
will be xt.
xt
Since
vector
yeah, eta is
minus
constant, I'm writing eta.
eta
This is
gradient of
gradient of f dash xt.
xt
So what is this gradient represent? So gradient is nothing but collection of the partial
derivative.
derivative. Okay. So is this clear?
Yes, sir. So
Yes,
where
sir.
the question you were showing in practice assignment,
Mhm.
please see the question number 3.
Okay. What is the issue?
So I was solving, but my answer not matching.
Not matching. Have you gone
My
through
answer
the?
was like 56 point something I get, and
Have you checked the solution PDF, by the way?
no.
Okay. So can you go with that and let me know whether you are getting or not? So I can tell you right now, that's not a problem.
Okay,
If you want, I
and please scroll down where the question you are solving. Just the next question.
this one.
Like here we are seeing minimum of, right? Here I was checking for minimum of, but here answer is maximum of. Why?
Yeah. So you okay? First of all, you need to understand. So what is what you want to optimize? So first of all, I want to find the best solution for my function, right?
Yes, sir.
Correct. So that best means what? I want least loss, I mean, or least error, or else maximum reward, right? So in the
Yes, sir.
previous question, it was cost, right? So see, it's very obvious, right? You want to minimize your cost. correct?
Yes, yes.
In this question, what is the objective? It's asking profit per unit. So that means you want to
Profit.
maximize your profit, right?
Yes, yes, yes.
Yes, you don't want,
Yes.
see, you shouldn't want basically you are going to minimize your profit, right? That shouldn't be the case,
Sir,
right? So this is,
sorry for
Yes.
interrupting you once again, but you are low on battery.
oh yeah, sorry. Let me connect with charging point. Give me a minute. Okay, can you hear me now?
Yes, sir. Sir, please check the last question.
Okay, where it went? Yeah, so now it's clear. You want to
Yeah, yes, yes,
maximize
yes.
the right,
Profit.
55x1 plus 15x2, correct?
Yes.
Okay,
The
is this
last
clear?
one, yes.
Last one, this we want.
Yes.
Like you want to solve this
So
right?
actually, I was just unable to compare with values x sin x minus 1 by 2 because we should, I have to put the values minus 7 in place of x, right?
You have to calculate radians in radians.
Yeah, go ahead. So basically, you have doubt this x. See, what is it will be? First of all, we have to apply this part, right?
Yeah.
Solution. So what is the for initial guesses?
Initial
After
guesses is
two,
minus
it
7.
is asking after two iterations, right?
Yes, yes.
So what you have to do basically, you can try it out. So you have to, it will be xt plus 1 equal to xt minus eta times f dash xt, right? So you
Yes.
have to find the, what is the f of x? So f of x is
Minus
uh,
7.
x,
X sin
x
x minus
X
1 by
not
2.
x
minus
sin
2.
minus
What will be f dash x?
X cos x plus sin x by 2.
Yeah,
X
tell
cos
me.
x, x
Hmm.
cos x plus sin x by 2.
See, 1 by 2 you can take out, that's not a issue. Or else you can define like this basically x by x and x by x into sine x minus by 2 minus 1 by 2. Correct?
yes, so
Yeah.
we can part way.
Okay, what was the first derivative did you got? That's what my question.
So that's the confusion for me.
So if you have two, okay, what is the how will you proceed for this multiplication rule?
So actually, I was putting the value minus 7 in place of x.
Why? It's
And I
not asking
was,
f x naught, right? It's f dash x naught.
yes. Then
So first you have
firstly,
to calculate the derivative
derivative.
of this, right?
Yes.
So you have to compute the derivative. So it will be basically x into
Cos x plus
basically,
sin x.
yeah. So basically it will be x into cos x, and then for if you differentiate with respect to x, so sin x, and with respect to x it will be 1, right? So this will
Yes.
be this divide by
2.
2. Correct. So what will be f dash x naught? So what is the x naught? It's a minus 7.
Minus 7.
It will be minus 7 cos of minus
Minus
7
7.
and plus
Sine
sine
of
of
minus
minus
7
7 divided by
by
2.
2.
So just substitute this value and you will get the answer, right?
Yes. Yes, yes.
Okay. Okay.
I
Yeah.
just not differentiate the parts.
No, no, no. So you should be clear with this notation. This is the
Yes.
first derivative at
Yes.
that point. Okay.
Okay.
Okay. Well, so now, so first question is here we have to find out this objective function is given to you. This f of x y is x square plus y square minus 4x minus 2y plus 5. So what is the You have to first of all you have to use the gradient descent algorithm with an initial guess of 3 comma 2, and the learning rate is 0.1. So what is this 0.1? 0.1 is eta is given to you, right? And what will be the x comma y after one iterations? Basically it is asking x1 y1. Is the question clear to everybody?
Yes, sir.
Yes, sir.
Yes,
Well,
sir.
so
Firstly,
how?
we will
Yeah,
see
so what is
partial
the formula?
derivatives
It's
and put on the values.
xt plus 1 vector equal to xt minus eta times gradient of f of xt. So what does this mean? So here what is the xt plus 1? So basically if we want just for after one iteration, that means I need x1
Yes,
y1
y1,
equal to, this is x naught
x
y
naught, y
naught
naught,
minus eta is let's make it
zero
eta. And
point
what is
0.1
this del f of xt? It's saying del f yeah, del f del
by
x
del del
and
f,
del y by del f
del
divided
f
by
by
del
del
y
y.
at x naught and y naught. Understood? This is the something you have to calculate. So I am giving you 2 to 3 minutes. Please do it and let me know what answer you are getting.
Option D.
Okay, have calculated or you seen some more?
Calculated.
Okay, great then. Option D is correct option, but I'm giving you time to check it and let me know whether it's actually it's correct or not.
It is correct.
Correct, huh? Okay,
Yes.
great. Should I solve it? So what
Sir,
I
option,
need?
sir, option D.
Option B, D, right? So what is this? Is f of x comma y. So
Yes,
this
sir, option
f
D.
of x comma y is x square plus y square minus 4x minus 2y plus 5. So what is the gradient of this f at x comma y? So first of all,
2x minus 4.
this is del f, del x, del f, del y, right? So what is the del f, del x? So 2x minus 4,
2x minus 4.
and this is 2y minus
Another
2.
2y
2y
minus
minus 2, sir.
Yeah.
Well, so what will be this gradient of f at x naught comma y naught?
2 and 2.
So
2
2
comma 2.
into 3 minus 4, that is 2, and
No,
2 into 2 minus 2, that is 2. Is this clear to everybody? This
Yes,
Yes.
question.
sir.
So this x1 y1 is x2 x naught y naught, that is 3 2 minus eta is 0.1, and this is 2 2. So basically it will be 3 2 minus zero point 0.2 zero point 0.2, so it will be 2.8 and 1.0.
8.8.
So, this is the answer. You can see. So this question has been asked in one of the PYQ. So you can see how simple it is, right? The things which we have done already, we have to apply that concepts only. Okay, is this clear?
Yes, sir.
Okay, if that is clear, then can you try this also? Here learning rate is different. You can see learning rate is we have changed. So you, it's not eta is given to you directly, you have to apply something. Okay, so please try to do it and
So for
let me
first
know.
eta it will be something and second eta it will be something else.
Yeah, whatever.
Okay.
Yeah, just yeah, it will change, right? So because for t is equal to 1 means it will be 1, for t is equal to 2 it
1
will
by
be 1
4.
by, yeah, and it is asking just two till after two iterations. Okay, if someone has calculated, what is the x1, y1 you are getting? If someone has done.
7, 4.
Okay, 7.
7 and 4.
Okay, okay, well.
Option B.
Option B. Okay, I got one vote. I will wait for few more minutes. That's not an issue.
Yes, sir. Option B.
Option D.
B.
B. Okay. Okay, so is what about others? Others are trying, right? I hope.
Yes, sir.
Okay.
Yes, sir. Option B is correct.
Okay. So I will wait for one more minute, then I will proceed. Okay. If you want more time, I can wait. That's not a problem. Please feel free to say. Done? Shall I proceed? Or you're trying, then I can wait.
Sir, you can solve, sir.
Okay, I can solve. Okay, well.
Sir,
So
B.
what B? Okay, great. So I think majority is with B. So what is the formula? So it's x t plus 1 is equal to x t plus eta gradient of f dash x t, right? Correct? That is the formula, not f dash, because we are using already. Sorry, I think it should be minus. Minus. Okay, well. So we have used correct. So B is the correct. Let's see how. So what is the gradient of f x comma y? So it's nothing but gradient of f. I mean del f del x del f del y. So what will it be? It will be 6x minus 6 y, right? And then it will be minus 6x plus 2y, correct? Am I right? So what is this gradient f at x naught y naught? What is the f naught x naught y naught? Because this will be same, right? This is not going to change. Only eta will be changed. So this will be 1 2. So minus 6.
Minus 6 minus 8.
Minus 8.
Minus 8.
Sir, minus 10 now, sir.
So 6 into 1 minus 6 into 2 minus 6. So 6 into 1 plus 2 into 2. That is minus 2, right?
Sorry, minus 2.
Yes, sir.
Am I right? No, so see, this eta will get changed, right? So because it's saying for each iteration. So for the iteration 1, so for iteration 1, what will be the formula? It will be x1 y1 equal to x naught
X naught,
y
Y
naught
naught,
minus 1
minus
by 1 square root, right? Into minus 6 minus 2. So basically what it will be, x naught y naught is 1 2 minus 6 minus 2. So basically it will be 7 and 4.
4.
yes,
That's correct.
yes,
Now
sir.
what is the after second iteration? So iteration 2. So at iteration 2, what will be eta? So eta, it will be 1 upon t square, that is 1 upon 4.
4.
So what will be my formula? Formula will be x2 by 2
X2,
will be
Y2 is equal to
x1
X1, Y1
minus 1 by 4. Sorry, so this will be gradient of f x1 y1. Okay, sorry, it will be same for it's not, I mean, that was incorrect statement. So it will change, right? It will change for each iteration. So
Yes, it will
what
change
will be
now
del
for
f
7, 4.
x1 y1? So what is the x1 y1? It's a 7 4 minus 1 by 4. So we have to substitute 7 4 here, right? So it will be
Yes, sir.
42
18,
minus 24
18.
18. Yeah.
And for
Then
Y, it is minus 34.
minus 34. Okay. So it will be 1 by 4. So it will be something, it's coming out to be 18 by
2.5,
4. Okay. 2.5 directly. Okay. And then
12.5.
12. Okay. So I think this is the answer, right? Yeah. This is the answer. So your x2 y2. So this update after the second iteration is 2.5, 12.5. Correct?
Sir, I have one doubt, sir.
Mhm.
Sir, the value you're plugging into the gradient will change, but not the differentiation. So once you differentiate it partially with respect to
Yeah,
the
I
y,
have
x and y, it
differentiate
remains.
here. Yeah, I have differentiate here. I just substituted x1 y1 here, right? Here I substituted x naught y naught. Okay,
Okay, sir. Got it, got it.
clear? Yeah.
Sorry, sir, for clarification, x naught and y naught means what we are substituting the value of
Initial
0 or
starting
1.
point. This is starting point.
Okay, so after differentiating, we got the 6x minus 6y and 2y minus
So
6x.
this six
After
x
that,
minus six
how,
y minus, yeah, this is general gradient of f(x) in terms of x comma y.
okay, sir.
Now I'm asking what is the value of this gradient at x naught y naught. So if you
Yes,
substitute
sir.
what is the value of this gradient at 1 comma 2. So you have to substitute x naught as 1 and x y as 2. Okay, that's what we
Oh,
are doing.
okay, sir.
Clear?
That is the part I
Yeah.
was actually confused. Now, okay, sir. Thank you, sir.
Okay.
Sir, can
Okay.
you explain in second iteration how did you get 1 by 4?
So in the question, see, eta is not fixed here. So okay, in beginning, in the previous question, it is clearly mentioned eta is 0.1. So at each for every iteration you have to take eta as 0.1 only, right? You can see I took 0.1 here, right? But in this question, in the second question, it is saying eta is the 1 upon t square, where t is equal to 1 2 3 and so on. So if t is equal to 1 means for first iteration, what will be the learning rate? What will be the eta? It will be 1. Correct? 1 upon t square 1. What will be iteration 2? For iteration 2, it will be 1 upon t square. Right? That's what.
Okay. Okay.
Clear? Yeah.
Yes, sir.
So the next question is, it is asking, you have been given fxy x minus 1 whole square plus y minus 2 whole square using a gradient descent algorithm with an initial guess of 0 0. Learning, see, now here learning rate is same, right? It is not going to change for first iteration and second iteration and so on. And what will be the absolute difference between the value of the function after first iteration and second iteration? What is it is asking? What is the answer? What is the meaning of the question? It is
Sir, we
asking
have to
what?
find the x1 and x2, and then we have
Mhm.
to put the values into the. We have to find basically f of x1 and f of x2 and find the
Correct.
absolute difference.
Basically, we have to find the value f1 means this update after fx1 y1 and f2 is f of x2 y2, and you have to find the absolute difference between f of f, right? Understood?
Yes, sir.
This is something you have to calculate. So I'm giving you some 3 to 4 minutes. Okay, would you like to solve it, or you want to?
Yes, sir. Give us 2 minutes, please.
Okay, all right. Yeah, great. Thanks. Okay, so are you able to solve it?
Yes, sir. Just finding a difference.
No problem.
So 1.152.
Okay, yeah. So 1.152 is the correct answer. Very good. What about others? Are you getting same answer, or are you getting any different? If you're not getting the same answer, no problem. So maybe there is some calculation mistake, but the idea is you should be clear with the concept, how to apply. But anyway, so I will solve it. So should I wait if you are solving, or should I proceed?
So 1 minute, sir.
Okay, all right, no problem.
Yes, sir, 1.152.
Okay, all right. So, shall I proceed?
Yes, sir.
So, okay, what we have to do? What is the gradient of this f x comma y? It's a basically we have to. This is del f divided by del x, del f divided by del y. So what will it be? It will be 2 times of x minus 1 and 2 times of y minus 2. Correct? So what will be the gradient of this at, okay, let's we will calculate it later. Anyway, so what is this x1 y1? First of all, what is the x1 y1? It's a one more page. No, I have to somehow adjust here. So it's a x naught y naught minus, what is the eta? Eta is 0.1. What is the this is something I have to find gradient of f at x naught comma y naught. So x naught y naught is 0 0 minus 0.1, it's 0 minus 2 and minus 4, right? So it will be minus 2 minus 4. So basically it will be 0.2 and 0.4. Am I right?
Yes, sir.
So what is the value of f1? F1 means I am talking about f of x1 comma y1. So you have to substitute 0.2 minus 1 whole square. This will be 0.2 minus 1 whole square plus 0.4 minus 2 whole square. What it will be? Minus 0.8 whole square, that is 0.64 plus
36.
point minus 1.6. So I think if
So,
I'm
but
not
we
wrong,
were so we will put the value in the partial gradient part, right? Not on the exact.
no, it is asking what is the value of the function after first iteration. So after first iteration, you got this value, right? 0.2,
Yes.
0.4, right?
Yes.
Now, after first iteration, what is the value of the function, right?
Okay. Okay. Okay.
General, it was this. At 0, 0, you will get something. So this will be what? What is the value? So 64.64 plus 2.56. What is the value? 3.2. If I'm not wrong, can you cross check?
3.20.
Well, what is the next we have to calculate? I have to calculate. I have to go for the second iteration, right?
X2
So
Y2
h2 y2, it will be
X1
x1
Y1
y1 minus
minus
zero point 0.1
0.1
gradient of f at x1 y1.
Y1.
Now you have to calculate this part. So x1 y1
Yes.
is 0.2,
0.2
0.4 minus 0.1. What is the grade? What is the gradient of f of x1 y1? Anyone can
Minus
calculate? Can let
1.6.
me know. Okay, minus 1.6 and it will be again in
Minus
minus only,
6.
minus 3.2, right?
Minus 1.6 or minus. No, no, right.
Right? Am I right? Yes or no?
Yes, sir.
So what it will be? It will be 0.2 plus 0.16, right? So basically it will be 0.2 plus 0.16 and it will be 0.4 plus 0.32. So basically what is the answer you will get? 0.36,
36
0.72.
72.
So this is x2 y2. Now what is the f2? F2 is nothing but value of f x2 y2. So this will be basically you have to substitute
36
0.36 minus 1 whole square plus
plus
0.72
0.72 minus
minus
1.
2 whole square. Basically, what is the answer? Anyone can, those who have computed.
Okay.
Minus 0.64 square.
0.63 का whole square. 1.28 whole square.
6.
Right, so this will be, can anyone can calculate and tell me the value?
2.048.
2.048. Now, what is the final question? It is asking the absolute difference between this f1 minus f2. So f1 is 3.20. So 3.20 minus 2.048, which is nothing but 1.152. So that is the answer. Is this clear, everybody?
Yes.
So the next question is you have to find this using the Taylor series approximation. I think this is very straightforward. Would you like to solve it, or you want to? I mean, should I solve?
टेलर सीरीज हो दो तीन में जो बड़ा वायदा
Sorry.
Sir, give us some time. We will like to
Yeah.
solve it.
Okay. Great. Yeah. Please.
Actually, sir.
Yeah.
So this the second part. This we have to subtract the value from new value x minus one and this y minus two. Please show the last part of the question.
Hmm.
Okay, okay. I see.
Clear?
Oh, yes, yes, correct, correct.
Is it 4?
I need to calculate it.
Sir, 4 is the answer.
Okay. So both of you, I mean, two of you got 4 as the correct answer. So I assume that is the correct. But
Yes, sir.
anyway,
4
let's.
is the correct
Yeah.
answer.
Okay. Okay. That it seems then 4 is the correct answer. Okay. Let me solve it. So what should be the approach? What should I write first of all? I should write. So for this multivariate, so I can write this as f of x. So this x is in vector, right? So at any point x, right? So this is vector, correct? So this is nothing but this should be approximately equal to f of x naught. This is again x naught is the vector plus gradient of f of at
X
x
naught
naught. It should be transposed
transpose is
into x
x
minus x.
minus x1.
Is
Yeah.
this clear to everybody? Right? Yes, no?
Yes, sir.
So what is the x minus x naught? So first of all, what is your x? So x is this 2, 2, 2, right? So x is 2, 2, 2. And what is the x naught? X naught is given to us as a, yeah, what is x naught? Tell me. 1, 2, 3. Correct? Yeah, this
Yes,
is
sir.
your x naught.
Yeah.
Now, so what is x minus x naught? So it will be 2, 2, 2 minus 1,
Yes.
2, 3. So it will be
0,
1
0, minus 1.
minus 1. Well, and what is this part? Gradient of f x naught transpose into x minus x naught. So you can see this is x naught, gradient of f x naught transpose. This is x naught. So basically, it will be 1, 5, 7
times 1, 0.
into 1,
1.
0, minus 1. So it will be 1. Basically, it will be 1 into 1 plus 0, 6, right?
Minus 6.
Minus 6.
Yeah.
Minus 6. Yeah, minus 7.
Yeah.
Yeah. So this is minus 6. Correct? Now, what will be the final answer? So f of x. So this will be f of x is what? This is nothing but 2, 2, 2 transpose is approximately equal to f of x naught. So what is the x naught? I can write the 1, 2, 3 transpose plus this part, right, which is -6, correct?
Yes, sir.
10
So
plus minus 6.
10 minus 6, which is 4. So 4 is the answer. Okay, clear to everybody? Okay.
Sir, I have one doubt, sir.
Uh,
Sir, on what basis we took x naught and x, sir?
See, what is the Taylor series expansion set? So you want to compute the function at any f of x plus eta d, which is approximately equal to f of x plus eta d into f dash x, right? Plus eta square d square divided by 2 factorial f dash f double dash, correct? And so on, right? So here we want to find the value of this function, right? So you can consider as a, let's say, vector x. So I want to calculate at x, right? This is a something I want to calculate, right?
Yes, sir.
Yes or no?
Yes,
This is
yes,
the
sir.
point we have to calculate. So that means this is given to us. This is x naught. This is x naught. You can treat as x. That's fine. That's no problem. Okay.
Okay, sir. Yes, okay, sir.
Now is this clear?
Yes, yes, sir.
So there is one more question. I think so everyone please try it out. You can try it later. So this is kind of homework to all of you. Okay. This is simple itself. You have to find the maximum. You have to basically product is maximum. So this is exercise or homework, you can say. If you are not getting anything about it, you can tag to us. That's not problem. I will be giving you answers. So what do you want? Okay, you can try it later. Will that be fine to everybody? Yes, no?
Yes, sir.
Yes, sir.
Yes.
Okay.
Okay, sir.
Okay. So that's all from my end actually for today's session. Okay, so if you want, I can give you hint
No,
about
could
this.
not see. Questions could not see, but let's me. Profit is good to.
See, if you want, I can give you the hint about this question. Okay, so there is two products, right? A and B, right? And it is X and Y denote the prices per unit of A and B respectively. See, this is just a bit different question. That's why I'm giving you as a homework. The
X
sum
plus
of
Y
prices
is
for
equal to
each
60.
unit. Yeah, two goods is 60. So what is the constraint? So what is the function? So function is it's a 2x square y. What is the constraint? So constraint is, see, why I'm not discussing, because this is something you can discuss in week 9, but this is solvable also. It's very easy. So if you see this x plus y should be equal to 60, correct? What
60.
next you can do? You can
Substitute
X.
y.
yeah, that is the key point. So
Yes.
later you will get some function in terms of x. Let's say p of x. It will be 2x square 60 minus x. Now what is the job here? Now you have to
So
find
we'll
the
Maximize.
firstly
yeah. So basically you have
first
to find
derivative.
out p dash x. You have to equate to with 0,
So
and you have to
firstly
check.
multiply and then derivative.
You have to see multiply by what?
So 2x square into 60
Yeah,
minus
yeah,
2x
yeah.
and
So
then
then you
first
have to check with
derivative.
the second derivative. Yeah, this is less than 0 or not. If this is less than 0, then this is the maxima. And finally, you will get some value of x from here. You will substitute here. You will get some value of here. So basically, answer is A.
Yes.
You can cross check. Okay.
Yes.
Okay.
Okay. This is the way you have to proceed. So yeah, so that's all from my side for week 7 and week 8. So I hope things are clear to everybody. Whatever the concepts we have discussed, is anybody anything else? Is
Sir, I don't
idea is
have
to just
doubts related to I don't have doubts related to concept, but for quiz 2 we have from week 1 to 8, no, sir?
yeah, week 1 to 8. Yeah, major focus will be from week 5 to 8.
So
Major
what are
syllabus
the
will
Sir,
be from
like what will be the approximate split up, like
see, it's
approximate
not
split
like
up, like how
approximate
much percent it will be
split.
quite?
So major means you can expect some, around, it's not, I can't say it's exact, but around something, 65-70%, something like that. Okay,
Sir,
but
do we
majority
have
will be from,
recording for
Okay,
the
70%
first
will
session
be
of the first session?
sorry. Yeah, you can find out, you can find all the sessions from the playlist link, okay, within the playlist.
Okay. Sure.
Okay, so from the playlist you can find all the link, all the YouTube link of all the sessions, whatever the sessions happened till now. Okay.
Sir.
Okay.
Hmm.
Sir, and also upload the PDF.
Yeah, I will upload under supplementary content. So after this session, I will add the YouTube link in the playlist, and I will upload my notes in the that part, supplementary content. Within supplementary content, you can find one folder called instructor session, and you can find there. Okay. So okay, is this clear? Is this all right to everybody?
Yes,
Yes,
sir.
sir. Thank you.
Yes, sir.
Okay, thanks all. I hope you
Thank you,
Thank you,
sir.
have
sir.
somewhat you learned something. So thanks all.
All
All the very best. All the very best for your quiz to exam. Yeah. Okay. Thanks. Bye.
Yes.
Thank you, sir. Good night.
Thank you, sir.
Thank you, sir.
Thank you, sir.